Welcome to Back to Basics. We are almost ready to have a look at collisions and how we measure them. But there is something else that is important before we do that. The energy of movement is called kinetic energy. It's how much mechanical energy an object has because of its mass and velocity. Kinetic energy is worked out using the equation where the kinetic energy in joules is equal to a half times the mass of the object, multiplied by its velocity squared. So, objects that are moving very fast, like a bullet, have a great deal of kinetic energy. Now, when objects touch or separate, they exert a force on each other. There is also movement involved, so that generally means that work is being done. Work, if you remember correctly, is calculated by using the product of force and the displacement of movement. Here is where things get a little tricky. Even though we're using vectors to calculate work and energy, the answers to these questions is not a vector. Energy is simply a quantity of something that an object can have. Kinetic energy has velocity squared, so even if the velocity is negative, the answer to the equation would always be positive. An object can never have a negative energy. It can lose energy, but never have a negative value. Let's look at a system. There are two objects moving along a straight line here, one with a positive velocity, one with a negative velocity. The velocity of these have different signs because we have indicated that the object on the left is moving in the positive direction. So, even though the velocity of the objects is of opposite sign, we see that object A, with a mass of 5 kilograms and a velocity of 15 meters per second, has a kinetic energy of 562.5 joules. Object B, with a mass of 15 kilograms and a velocity of -5 meters per second, has a kinetic energy of 187.5 joules. It's worth noting that mass and velocity had a different effect on the energy of the object. A higher velocity is squared, having a much bigger impact on the total energy. Something else worth noting is the law of conservation of energy. It states that the energy may not be created nor destroyed, but transformed or transferred from one form or object to another. It might seem a bit strange, but even when objects stop suddenly and no longer have kinetic energy, their energy is merely transformed into another type. Now, there is a risk of misunderstanding here. We are talking about all types of energy in an object and its surrounding when we say that energy must be conserved. Some energy might have been used to change the shape of the object. Some of the energy might be lost as heat or transferred to the air as sound energy. The total amount of energy in an isolated system always remains the same. It just moved around and is shared between objects and types. Be careful of saying that energy is lost. It's merely transferred out of an object or changed into a different type, like potential energy or bond energy or even sound energy. So the kinetic energy in a moving system always comes from somewhere and always goes somewhere, but the amount remains the same.